When we multiply something by itself, for instance, x plus 3 squared, you remember I was very adamant that under no circumstances is it x squared plus 3 squared. No, 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 no. It's a trinomial, 3 terms. Why? Because squaring means multiplying by itself. And when we have that, we would FOIL. We would get x squared plus 3x plus 3x plus 9. We combine the middle. There's 2 of them. We got x squared plus 6x plus 9. We had a formula. The formula was a plus or minus b squared would be a squared, and then plus or minus whatever we had, twice the first times the second, 2 times a times b, and then always plus, because even negative times negative is plus, square the second, b squared. And if we use the formula here, square the first, x squared, plus, because it's plus, 2 times the first times the second, plus square the second, gives us x squared plus 6x plus 9. I like to think of the middle as twice the first times the second. First times second here is 3x, double that, 6x. Why am I pointing out the multiplication formula again? What am I driving home about factoring? Factoring is the multiplication process in reverse. So if we have the direction factor x squared plus 6x plus 9, our answer is going to be x plus 3 squared. So let's see what the process of recognizing and getting this would look like. Now, x squared plus 6x plus 9, we can do this the other way. Numbers that multiply to positive 9 and add to positive 6. The numbers aren't just 9 and 1, 3 and 3. In fact, plus 3 plus 3. So x and x, because of the x squared, the numbers we found are plus 3 and plus 3. When we multiply something by itself, that means we're squaring. Problem is, not all of them will be that easy, is the nice way of putting it. So it'd be nice to have a process we can use when the square is a potential answer. And here's going to be our recognition. When we recognize that we have a trinomial and that the first term is a square and that the last term is a square, here we recognize that 9 is 3 squared. Here we recognize that x squared is x squared. What we would have to check is 2 times x times 3. If 2 times the first times the second does in fact give us the middle, and in this case, 2 times x is 2x times 3, that does give us 6x. When it checks, we can make our square. We can make our square. This sign here is the sign in the middle. And then we put our 2 things in, the x and the 3. So let's say we have 4x squared minus 36xy plus 81y squared. Well, we recognize that 4x squared is what we get when we square 2x. We recognize that 81y squared is what we get when we square 9y. So we want to check, is 2 times the first times the second, is 2 times 2x times 9y 36xy? 2 times 2x is 4x. 4x times 9y is 36xy. So yes, it checks. What does that mean? It means we are magically able to set up our square. Because it's a minus here, it is a minus here. We put in our 2 things, the 2x and the 9y. Why do we have to check for the middle? Well, because if we get anything but that middle term, it doesn't factor to this. Maybe it's prime, maybe there's something else to do. Let's do another. Nine y squared minus 12 yz plus 4z squared. I recognize here that I have 3y squared, and here I have 2z squared. 2 times 3y times 2z, that's 6y times 2z, that's 12yz. That is the middle term. I set up my square. Since it's a minus there, it's a minus in the middle. And my 2 things are 3y and 2z. Formula makes it quick and easy. And this is for factoring a perfect square trinomial, something in the form a squared plus or minus 2ab plus b squared. Let's say we didn't use the formula here. Well, then we have this same problem, 9y squared minus 12yz plus 4z squared. There's nothing that we can factor out everywhere. We have two variables, so I'm going to make it 9y squared minus 12y plus 4. I'm dropping the z's. We're going to come back to those later. We're going to factor here. AC, the multiplication goal. A times C, 9 times 4, that's positive 36. B, the addition goal, that's going to be negative 12. The numbers that multiply to positive 36 and add to negative 12 are negative 6 and negative 6. When it's the same number, that's a clue. It's going to be a perfect square trinomial probably. Since this was a 9y squared, airplane method says 9y, 9y. What we just found, we're putting in our numbers, minus 6, divide by what we can, 9 and 6, divide by 3. 9 and 6, divide by 3. This is 3y minus 2 times 3y minus 2. This would give us 3y minus 2 squared. But wait a minute, that's not our answer, because what did we do in the beginning? We took out the z's. I said we were going to come back to them at the end. And how do we account for it? Just put it with the other one. So instead of minus 2, it's a minus 2z. And that's our answer. So you can still do it if you don't know the formula. I want to mention that there is a method that I've completely skipped over. It's called the trial and error method, and it's quite the pain. Quite the pain indeed. It's basically what it sounds like. Trial and error is guess and check. Could take a long time. You could get lucky and it could be right away. If we had something to factor that was like, I don't know, 6, let me pick an actual one. If we had something like 14a squared plus 13a minus 12, and we didn't know anything. One thing we do know is that this is probably some binomial times some binomial. And to get a 14a squared, maybe it's a 14a times a 1a. Or maybe it's a 7a times a 2a. Or maybe it's a 2a times a 7a. Or maybe it's an a times a 14a. And then the last one for negative 12, maybe Maybe it's -6 times +2. Or maybe it's +12 times -1. Or maybe it's -4 times +3. We know that the first ones have to give us the first. We know the last ones have to give us the last. So you would write out every combination of these and those. There could be dozens, depending on how many factors these numbers have. And then you would FOIL each and every one of them until you find the ones where the outer and the inner work out to what you need. So just from that explanation, hopefully you understand why I'm skipping over that, why guess and check when we have these lovely methods that are guaranteed to get us our answers every time within the confines of a timed environment. Okay. Objective 2 in this topic, factor the difference of two squares. Objective 2 in this topic, factor the difference of two squares. Just like in the last lecture, we looked at, hey, we can factor a perfect square trinomial, and we get a plus b squared, or a minus b squared. And that's the reverse of a special multiplication formula, because multiplication and factoring are reverses of each other. They're inverses. They go back and forth. If we factor, we get an answer. If we multiply that answer, we get the factored form, or the thing we factored. It just goes back and forth. Remember this one? A plus b times a minus b. We did that a few lectures ago, and we saw that this is a difference of squares. When we have a plus b times a minus b, we can do a squared minus b squared. Well, if we reverse it, we have a factoring formula. If we have a difference of squares, this factors to a plus b times a minus b. If we're subtracting two things squared, we set up conjugates, 1 plus, 1 minus, everything else the same. And then we plug in the first thing and the second thing. So the first thing and the second thing, first thing and the second thing. So let's say we had something simple. Let's start simple and just keep going. Make it harder and harder. If we had x squared minus 9, we know that this is a difference of two squares. X squared is what we get when we square x. 9 is what we get when we square 3. So the two things being squared are x and 3. To factor it, two binomials, conjugates, so 1 plus and 1 minus. X and 3 are the two things, so x and 3. X and 3. And that's that. What if it was a 16x squared minus 9? Well, 3 squared still gives us 9, but it's 4x that we square to get 16. Two binomials, conjugates, 1 plus, 1 minus. 4x and 3 are the two things, so 4x and 3. 4x and 3. King of the castle, king of the castle. That's all it is, the Borat method. If you didn't get the reference I just made, I'm not going to explain it, but if you got it, it might help you work your way through this. As Britney Spears might say, or might be forced to say, who really knows these days, gimme more. Here we go. Let's say we have 98 C squared D minus 50 D squared. Well, these don't look like squares to me. And actually, I wrote this wrong. This should be 50D cubed. And you know what? It still doesn't look like squares to me. But what is the first step of any factoring problem? GCF. Find a greatest common factor if it exists and factor it out. Here, 98 and 50 can both share a factor of 2. So we can take a 2 out. D and D cubed, we can take a D out. You can see how these lectures have been building. A few lectures ago, it was this that was the new. Factor out a GCF. That was the new material. Now that's old material. That's something we know how to do. What's left over? 49 C squared minus 25 D squared. Now you see why we're doing this example. This can be factored further using the difference of squares formula. We have two things being squared that are subtracted. What do we square to get 49C squared? 7C. What do we square to get 25D squared? 5D. So how does this factor? This wasn't factoring, this was just rewriting so that we can see square minus square. This is exactly the same as that. Well, you're glad I asked. It's a difference of squares. So we set up two binomials, conjugates, so 1 plus and 1 minus. Now take the Borat voice. The two things are 7C and 5D. So 7C and 5D, 7C and 5D. Wah, wah, wee, wah. Look at us. Boom. I had a comment from a student earlier in the semester that a few lectures had gone on without me making any movie or TV references and that they were worried about me. Thank you so much. Hopefully I'm filling my quota now. 2D times 7C plus 5D times 7C minus 5D is our answer here. Go complication. I just can't stop now. Z to the fourth minus 81. Well, this is a difference of two squares. This is why I always set everything up, even the easy ones, in the square minus square form, because it helps. What are the two things being squared? 81 is obviously just 9. There's no variable with it. What do we square to get z to the fourth? Why were exponent rules in the same unit with factoring? This is why. Remember, power to a power multiplies, so this must be z squared. Z squared squared is z to the fourth. Difference of squares, so two binomials. Conjugates, so 1 plus and 1 minus. That's what conjugate means. Everything's the same except one's being added and one's subtracting. And then we put in the two things being squared. Z squared and 9. Z squared and 9. So we're done, right? Look at that answer very carefully and tell me psychically why we are not done. Oh my God. Who's moving my hand? Hopefully it was you psychically telling me, hey, Z squared minus 9, difference of squares, we can keep factoring. We can't factor this anymore. A sum of squares is not factorable. So this is nothing. Z squared plus 9, if it was its own problem and it said factor this, the answer would be prime. Sum of squares, like x squared plus 25, that's always prime. But the answer here is not prime, because prime is only an answer you give if you cannot do even one single solitary factoring step. If you so much as take out a GCF, it's not prime. Okay, so here we can factor this one more, because Z squared plus 9, that's Z squared, or sorry, Z squared minus 9. That's Z squared minus 3 squared. So our final answer is actually going to be this Z squared plus 9, and then the factoring of our other difference of squares. Two things, 1 plus, 1 minus, Z and 3, Z and 3. Boom. And that is the final answer. But we're going to move on to our next example. Y cubed minus 6y squared minus 4y plus 24. Well, it's been a while since we've started with a 4-term thing. How did we do this? Well, let's think back. 4 terms. Nothing can be factored out of all 4. There's no GCF. There's no like terms to combine. So it was factoring by grouping. Well, let's factor by grouping then. Surely, since we're talking about it now, there must be some difference of squares that's going to pop up at some point. But in a world where we don't know that, we start like we start anything. No GCF, 4 terms, factoring by grouping, group the first 2 terms. We can factor out a y squared, and we're left with y minus 6. Here, we can factor out a negative 4. We're again left with y negative times negative 6 is positive 24. Factor out the common y minus 6. We're left with y squared minus 4. That's why we're doing this. So if we continue to factor, y squared minus 4 would be y plus 2 times y minus 2, because it's y squared minus 2 squared. The two things are y and 2, y and 2. So that's the answer here. One more. And then we'll move into the very last factoring topic. Let's say we have x squared minus y squared minus 6y minus 9. I'll give you a second to get your wrong idea out of the system. And while you're doing that, I'm going to move this down just a little bit so I can get it out of the light. If you're thinking, hey, x squared minus y squared, that's x plus y times x minus y. Wrong. Because it isn't just x squared minus y squared. There's other terms on here, so it unfortunately doesn't work that way. But what we do see is that this is an x squared, and this is a minus. So what exactly happens if we factor that minus out so that it's minus the rest of it? Is it possible that what we're left with is a square? Let's find out. If we factor out this minus sign, we have y squared Ooh, my phone battery is dying. Y squared plus 7y. Yeah, that's my phone up here doing all this. Plus 9. Double check we did that right. Minus y squared minus 6y minus 9. Yeah. Because we would check factoring out a negative by distributing that negative. Hey, and what did we do last time? This, since y squared plus 6y plus 9, that's y squared, that's 3 squared. What do we check? 2 times y times 3, that is 6y. Yep. So what is this? Y and 3 in the square, plus there, so plus there. This is actually x squared minus y plus 3 squared. And there was a lot to do to get it into that form, but we got it there, just using all these things that we've been learning over the last few lectures. We actually haven't done any factoring yet. We've just been rewriting, but the factoring basically takes care of itself now because we have a difference of squares. That's two things. There we go. 1 plus, 1 minus. The first of those things is x. Be super duper careful. The second thing is more than one term, the y plus 3. So we're not going to have a problem there. But we're subtracting the y plus 3. We're subtracting the entire blue thing. That y plus 3 needs to be in parentheses itself. So that when we simplify, nothing changes in the first one, x plus y plus 3. But in the second one, we distribute that negative. And we have x minus y minus 3. This would be the final answer. X plus y plus 3 times x minus y minus 3. Oh. Let me do one more of these. One that works out the same way. Maybe it's a little easier. If we had x squared plus 10x plus 25 minus y squared, these three terms are what we would recognize as a square. And it's actually x plus 5 squared. And then this is minus y squared. We don't really run into the same issues that we did. Two things, 1 plus 1 minus. I left more room in the front since the first one's bigger. The first one's x plus 5. The second one is just y. Since the second one wasn't the one that had more than one term, that was a lot easier to get done. X plus 5 plus y times x plus 5 minus y. Almost done. Thank you for staying with me. Let's kick it up a notch. X plus 1 squared minus 9. Well, this is the difference of two squares. X plus 1 squared is what we get when we square x plus 1. 9 is what we get when we square 3. So our two things are x plus 1 and 3. X plus 1 plus 3, x plus 1 minus 3. Simplify, we get x plus 4 and x minus 2. 1 plus 3 is 4. 1 minus 3 is negative 2. So this was a little different. Instead of just an x, instead of just a number, we had an expression squared. So we plugged that into our formula, and we just simplified from there. The third objective in this topic, factor the sum or difference of two cubes. The last two formulas we're going to talk about are what I call the SOAP formulas, not because they come from General Hospital or Hydra. Now, that would be blue soap anyway. I call them the SOAP formulas because it helps me remember the pluses and the minuses. SOAP in this case stands for same, opposite, always plus. What does that even mean? Well, right now, same, opposite, always plus. Say it. Right. Same, opposite, always plus. We use these formulas for sum of cubes and for difference of cubes. A sum of cubes would be a cubed plus b cubed, a sum of cubes. A difference of cubes, a cubed minus b cubed. Both of these are a binomial times a trinomial. A binomial times a trinomial. 2 terms, 3 terms. And that means that there's 1, 2, 3 signs. 1, 2, 3 signs. These signs are going to be the same as what we started with, the opposite of what we started with, and then always plus. So on the plus one, same, opposite, always plus. On the minus one, same, opposite, always plus. And then what gets filled in, the two things being cubed in order are A and B. So the first and the second squared, multiply them together, the second squared. The first and the second, the first squared, multiply them together, the second squared. And that's how it works. So I'll give you a second to finish copying these down while I prepare our examples, our final examples. All the stuff we covered today, and we still might get done a little bit early. Okay. Let's take a look at 8x cubed minus 27. This is a difference of cubes. We can write it as cube minus cube. 8x cubed is what we get when we cube 2x. 27 is what we get when we cube 3. So these are our two things. The SOAP formula, a two-term thing, a three-term thing, binomial, trinomial. Our initial is a minus. Same, opposite, always plus. The two things are 2x and 3. Square the first, 4x squared. That's what we get when we square 2x. Multiply them together, 6x. That's 3 times 2x. Square the second, 9. That's what we get when we cube 3. That's the answer. Thank you. Next. $125 t cubed plus 64 z to the 6th. This may be a sum of cubes. 5t cubed gives us 125 t cubed. 4z squared is what we cubed to get 64z cubed, or c to the 6th. 4 cubed is 64. Z squared cubed, multiply those together, gives us the z to the 6th. We're starting with a plus. 2 terms, 3 terms, same, opposite, always plus. The two things are 5t and 4z squared. Square the first, 25t squared. That's what we get when we square 5t. Multiply them together, 5t times 4z squared is 20tz squared. Finally, square the second. When we square 4z squared, we get 16z to the fourth. That's that. Finally, I want to do x to the sixth minus y to the sixth. This is a difference of squares. X cubed and y cubed are the two things being squared. So, conjugates, 1 plus 1 minus, x cubed and y cubed. X cubed and y cubed. This is a sum of cubes. Binomial, trinomial, same, opposite, always plus. X and y, x squared, xy, y squared. So that is a sum of cubes. We factor accordingly. This is a difference of cubes. We factor accordingly. Binomial, trinomial. It's a minus, same, opposite, always plus. X and y, x squared, xy, y squared. That had both of our special formulas we've learned in the same problem. That's it. Don't be scared off. X cubed y to the sixth minus 27z cubed. The first thing is actually get what we get when we cubed xy squared. We can see that this is xy squared cubed minus 3z cubed. Our two things are xy squared and 3z. We very carefully put them in the formula for the difference of cubes. In the binomial, our two things are xy squared and 3z. Then in the trinomial, we are going to square xy squared. We are going to multiply them together, 3z times xy squared. And we're going to square 3z. Simplifying, the trinomial becomes x squared y to the fourth, 3xy squared z, and 9z squared. The signs that we put in, since this was a minus, are the same, opposite, always plus. And that's it for this topic. The topic is solving equations by factoring and solving problems. The first objective in this topic, solve polynomial equations by factoring. It's been a minute since we've done any equation solving. And right now we know everything we need to solve a new type of equation in a new way. We looked at linear things before now, just x to the first power. And then we started factoring quadratic things. Quadratics are things that have an x squared. So something maybe in the form ax squared plus bx plus c equals 0. Now we would also say that a is not 0 here, because if a were 0, this x squared term would go away. We'd just be left with linear, not quadratic. And of course, we wouldn't want any powers higher than x squared, no x cubed, x to the fourth. Those would not be quadratic, although we will see, well, I won't spoil it. Okay, so we're going to start this from the ground up. When I say the ground, I mean the ground. What is 3 times 0? I said the ground. 3 times 0 is 0. Okay, good job. What's 0 times 5? It's not a trick. 0 times 5 is 0. Okay, smarty. What's 0 times 0? Yep, it's 0. What can we learn from this? If I have two things multiplied together, a times b, and I know the answer is 0, what can you tell me about a and b? Yep. One of them, maybe both, has to be 0, because if the second number is 0, we multiply and get 0. If the first number is 0, we multiply and get 0. First and second can both be 0. That gives us 0 as well. So in general, if a times b is 0, then either a equals 0 or b equals 0. This is called the zero product property. It's also referred to as the zero factor property. No matter what you call it, the point of it is that if we have a bunch of things multiplied together to give us 0, then either the first is 0 or the second is 0. And if there's more than 2, one of them has to be 0. How would we use this to help us solve equations? Well, let's say we had something like this, and I'll give it in factored form. X minus 4 times x plus 3 equals 0. Well, this is two things multiplied together, giving us 0. So either the first thing, x minus 4, is equal to 0, or the second thing, x plus 3, is equal to 0. We go on and solve both of these. Add 4 to both sides, x equals 4. Subtract 3 from both sides, x equals -3. When we solve an equation, we can check our answers to make sure that we're correct. If we plug 4 in, 4 minus 4 is 0, so 0 times 7 is in fact 0. If we plug -3 in, -7 times 0 would be 0. So both answers check. So we say x equals 4 or x equals -3. Or we can write our solutions as a set, 4 and -3. So you can see we're not doing anything new in terms of factoring. But this is showing us that if we have a factored form on one side and 0 on the other, we could then apply the zero product property to solve for the missing variables. And this strategy is going to be used on all of the problems. The only thing I can do to make this harder is to kind of mask the original problem, and we'll have to do some sort of factoring in order to solve. We're going to get everything on one side, 0 on the other, factor, and solve. Everything on one side, 0 on the other, factor, and solve. Over there, everything on one side, 0 on the other, factor, and solve. You. Yes, you. Stand still, laddie, and repeat after me. Everything on one side, 0 on the other, factor, and solve. Here's a quadratic equation because we have an equal sign. We have everything on one side, 0 on the other. What do? Factor and solve. So to factor this, it's an x squared, so x and x. The numbers that multiply to +8 and add to +6 are +4 and +2. Even if you're doing that in your head, write this out. This is showing work for a factoring problem. I want to be clear about that. There is work to show. Even if you do it in your head, if you're finding numbers that multiply to something and add to something, you put that down on the page. Come final exam time when I grade the work, that's what I need to see. Picking the multiple choice on the final exam isn't going to give you credit. Showing your work, because I grade the work, that's going to give you credit. So get in the habit now of showing work on factoring problems. So +4 and +2. That's two things multiplied together equaling 0. So either the first thing, x + 4 = 0, or the second, x + 2 = 0. Subtract 4 from both sides, we get x = -4. Or subtract 2 from both sides, we get x = -2. We just solved this quadratic equation using factoring. Everything on one side, 0 on the other, factor, and solve. (2x² minus 5x = 12. Is everything on one side with 0 on the other? No. So what are we going to do? Get everything on one side, 0 on the other, factor and solve. So let's subtract 12 from both sides. That kind of brings it over to the left. 2x squared minus 5x minus 12 equals, well, we got rid of the stuff on the right. Got rid of plus 12 with minus 12, and we're left with 0. Everything on one side, 0 on the other. So what do? That's right, factor and solve. We got a 2x squared. Let's go airplane method. So 2x and 2x. A times C, 2 times negative 12. We're looking for numbers that multiply to give us negative 24 and add to give us negative 5. These numbers are going to be negative 8 and positive 3. Negative 8 plus 3. We can divide 2 and 8 by 2. We're left with x minus 4 times 2x plus 3 equals 0. So what have we done so far? We've gotten everything on one side, 0 on the other. We use the airplane method to factor this. X minus 4 times 2x plus 3. Now we're going to use the zero product property. Either the first thing, either x minus 4 equals 0, or the second thing, 2x plus 3 equals 0. Add 4 to both sides, we get x equals 4. Subtract 3 from both sides, 2x equals negative 3. Divide both sides by 2, x equals negative 3 halves. So our answers, x equals 4, x equals negative 3 halves. We use the word or. As a set, negative 3 halves, positive 4, or positive 4, negative 3 halves. Order doesn't matter when we write a set. It's different from an ordered pair. We'll learn about those eventually. Let's do another. Actually, instead of another, I want to come back to here for a second, to the 2x squared minus 5x minus 12 equals 0. Remember, we found our multiplication goal of negative 24, a times c, our addition goal, negative 5b. The two numbers were negative 8 and positive 3. I used the airplane method. I want to remind you, we can use factoring by grouping. Take this 3-term thing and split it up using these numbers. Instead of negative 5x, we can make it negative 8x plus 3x. So split it up. Then factor by grouping. Take out a 2x, x minus 4. Take out a positive 3, x minus 4. Then we factor out the x minus 4. We're left with 2x plus 3. So boom, we can factor it using the AC method and factoring by grouping as well. You're not bound to the airplane method, but you do have to know how to factor one way or another. I'm going to be using the airplane method a lot. If you need to use factoring by grouping, by all means, do that. Just make sure no matter what you're doing, you're showing some sort of work for the factoring. Okay. Y squared minus 2y equals 35. Is everything on one side with 0 on the other? No. So what are we going to do? Get everything on one side with 0 on the other. So y squared minus 2y. Let's subtract 35 from the right and then subtract 35 from the left, which leaves us with 0 on the right. We have y squared minus 2y minus 35 equals 0. Everything on one side, 0 on the other. Factor and solve. Y squared, so y and y. We need numbers that multiply to negative 35. We need them to add to negative 2. This is negative 7, positive 5. Those aren't the answers. Those are what we plug in to get our factoring. Then we use the zero product property. Y minus 7 equals 0, or y plus 5 equals 0. Add 7 to both sides, we get y equals positive 7. Subtract 5 from both sides, we get y equals negative 5. Negative 5 and positive 7 would be in our solution set. Let's do another one. This isn't so bad at all. Okay. 6x squared plus 8x equals 0. Everything is on one side. 0 is on the other. So what do? Factor and solve. This isn't a trinomial. We can't use AC method. We can't use airplane method. But what is the most basic type of factoring? What's the first type of factoring we went over? Factoring out a greatest common factor. And we know that's the first rule for factoring. If we see that there's a greatest common factor that we can take out of every term, we do that. Here, we can factor out 2x. Since our original had 2 terms, our leftover piece has 2 terms. 2x times 3x is 6x squared. 2x times positive 4 would be positive 8x. And there we go. There is a factored form now. We couldn't use a zero product property on this. That's addition of 2 terms. But we factored out the greatest common factor, and now we have 2 things multiplied together. 2x times 3x plus 4. When we have 2 things multiplied together equaling 0, we can use the zero factor property. So 2x equals 0, or 3x plus 4 equals 0. Divide both sides by 2, we get x equals 0. Or subtract 4 from both sides, 3x equals negative 4. Divide both sides by 3, x equals negative 4/3. So our solution set, negative 4/3, 0. 9x squared equals 21x. What is our mantra today? Everything on one side, 0 on the other, factor and solve. Is everything on one side with 0 on the other? No. So what are we going to do? We're going to get everything on one side, 0 on the other, factor and solve. I do hope that you're annoyed by that because you're like, I know it. Everything on one side, 0 on the other, factor and solve. Shut up. No. I will not shut up. You need to know this. It's called brainwashing. Okay. Someday, years down the road, I want you to just hear the phrase walking down the street, everything on one side, and you're just going to go 0 on the other, factor and solve. We're going to subtract 21x so that we have 0 on the right. Subtracting 21x from the right means we also subtract it from the left. I refer to this as moving it to the other side, but we're not picking it up and moving it. We're using our properties. We're undoing a positive 21x with subtracting 21x, and whatever we're doing on one side, we're doing on the other. Our same rules for solving equations. Those never change. Okay, so we have 9x squared minus 21x equals 0. Everything is on one side. 0 is on the other. Let's factor, because that's how we solve. What can we take out? We can take out a 3x. 3x times 3x is 9x squared. 3x times -7 is -21x. Now we have a factored form equals 0. What does that mean? Boo-boo. It means that the first thing, 3x, is equal to 0, or the second thing, 3x minus 7, is equal to 0. Dividing both sides by 3 gives us x equals 0, or add 7 to both sides, 3x equals 7. Divide both sides by 3, x equals positive 7/3. X equals 0 or x equals positive 7/3. As a set, just putting them both together, 0 and 7/3.